Okay, Algebra 1 fans, welcome to the beginning of a new unit here, and the topic for today is multiplying monomials using laws of exponents, okay, and something called the product rule. So first thing, let me tell you your algebra joke of the day. The question, why was 6 afraid of 7? And the answer, because 7 ate 9. Okay. First thing we need to talk about here, well, what is a monomial? Okay, what does it mean to be a monomial? Now, what we'll do here, there's some space on the side. Let's go ahead and we're going to write down the definition. A monomial is a number, a variable, a variable, or a product of numbers, and I'll abbreviate that with the number symbol, a variable or a product of numbers and variables with exponents that are whole numbers, with exponents that are whole numbers. Okay, so a monomial is a number, a variable, or a product of numbers and variables with exponents that are also whole numbers. So let me give you some examples here. That definition seems kind of confusing. So if we said the number 3, that's an example of a monomial. If we said x, that's an example of a monomial. If we said 3xy to the second, that is a monomial. Now, what is not a monomial, the exponents have to be whole numbers. So if I said xy to the negative 3, that's not a whole number because it's negative. So that is not an example of a monomial. If I said x raised to the 1/2 power, that's a fraction, that's a rational number, it's not a whole number. That is not a monomial. Okay, so it's a number, it's a variable, or it's a product where you multiply numbers and variables and the exponents have to be whole numbers, 1, 2, 3. It could be 0. If it was 0, then that would give us a different situation. Okay, so that's the definition. Now we're also going to do a little review here. When you're talking about variables, when you're talking about exponents, so this is x raised to the 4th power. The x, the bottom number here, the bigger number, is called the base. X is the base. And then this small number here, the 4, is what we call the exponent. When you raise a number to an exponent, when you raise a number, this exponent also we call it a power sometimes. So you could read this, okay, and I can write this down here. We could say this is x raised to the 4th. X raised to the 4th power. X raised to the 4th power. Or we could say x to the 4th. That's another way that we would read that. So what that means is whatever your base is, you're going to multiply it by itself 4 times. The exponent tells you how often you multiply it by itself. So x to the 4th is x times x times x times x. Now what you've done when you write it out like this with all these multiplying, all the variables multiplying, you expand it. That's what it means to expand it. Okay, so number 1, example number 1, expand 3 squared x to the 3rd. Well, 3 squared, that means we multiply 3 by itself twice, 3 times 3, and then x to the 3rd power means we multiply x by itself 3 times. Now all of this is multiplying, okay? 3 times 3, and then x times x times x. Now, one suggestion I have is that as we go through these examples, we're not going to work every single example, but for the ones that we do work, I would pause the video, write down your answer, work the problem, and then push play and see if I get the same thing that you do. Okay, number 2, expand a to the 4th, b to the 7th. Well, a to the 4th, that means we're going to multiply a by itself 4 times. A times a times a times a, b to the 7th, b times b times b times b times b times b times b. A to the 4th, b to the 7th. Okay, this is really interesting. We could do this all day long. Unfortunately, expanding can take you quite a bit of time. You can end up having to write down numbers or all these variables. It'd be nice if there was an easier way to do this. Now, we're going to reverse the process. We're going to simplify the following expressions. When you expand it, okay, you're writing it out. You're making it kind of bigger, the expression. When you simplify it, we want to put it together. We want to make it simpler. So number 3, you have x times x times x. If you're going to write that using exponents, we can write that's x, there's the base, and the exponent, you count the number of times you're multiplying it, it's 3. X raised to the 3rd power, or x to the 3rd. In number 4, a times a times a times a times a times a, that's a, the base is a, and the exponent is 6. A raised to the 6th. How many a's are multiplying? 6 of them. Number 5, 2, that's 2 raised to the 3rd, and then x raised to the 5th. 2 to the 3rd, x to the 5th. Now one thing we do, if your base is an integer, okay, 2 raised to the 3rd, we can simplify that. 2 times 2 times 2 is not 6. It's going to be equal to 8x to the 5th. That is simplified. 8x to the 5th. Then also notice we don't put a times symbol between 8 and x. We just write this is the coefficient. We write it next to the variable, and when you see this, you know it's multiplying. 8 times x to the 5th. Now, for something like for 6, 7, and 8, let's see if we can find a pattern here to this. If you look at x squared times x to the 3rd, we want to simplify that. We want to put them together. Okay, now, you can't add these. First of all, you can't add, you can't subtract because they're not like terms. They have different exponents. However, we can multiply them. Let's expand it first. X squared is x times x. And then x to the 3rd is x times x times x. Now, if you count this, how many x's are multiplying? It's x to the 5th. That's the answer. Let's do the same thing with number 7. X to the 4th times x to the 7th. X to the 4th, x multiplies 4 times. X to the 7th, 4, 5, 6, 7. Okay, that's a lot of x's there. Let's count them up. 1, 2. So we got x to the 11th. X to the 11th. Now here's the thing. Let's see if we can come up with an easier way of doing this. If you look at the exponents, x squared, x to the 3rd, 2 and 3, what was the answer? 5, x to the 5th. X to the 4th times x to the 7th. When you multiplied that, what was the answer? X to the 11th. How do you get 11 from 4 plus 7? You add it. How do you get 5 from 2 plus 3? You add it. So in number 8, if you were to write all this out, I'm not going to write this down because I'd have to write down x 6 times, and then I would write x 10 times, and then I would write it 2 times. Let's just do this. Let's take the exponents and add them. 6 plus 10 plus 2. That's the number of times you have to write down the variable. And what we get is x to the 18th power. And that's it. That's simplified. So what we've done here is we've discovered a rule. Exponent rule number 1. This is called a product of powers. Product is multiply. If you have the same base, okay, a raised to the m is the exponent, times a is the base raised to the nth power. Instead of writing all these a's down, the quick and easy way to do this is to say, take the base a, write that down, add the exponents. When you multiply the variables, you keep the base, you add the exponents. Right? And then at the bottom here is kind of a summary. When you multiply monomials and the bases are the same, keep the base and add the exponents. Now, if you have constants or coefficients, if you have integers in front of your variables, you just multiply those. You have to remember this is a multiplication problem that you're doing. So you are multiplying with this. But when you multiply the variables, what happens is you add the exponents. That's the rule. Now let's do some examples here. Let's flip this onto the back. All right, and let's look at number 9. A to the 6th times a to the 8th times a. If there's no exponent with the variable, it's automatically a 1. So we put a 1 in there. All right, I know that's kind of hard to see. It's kind of small. So what do? When we multiply the variables, we keep the base and we add the exponents. 6 plus 8 plus 1, and we get a raised to the 15th power. That's it. In number 10, first thing I do is I take the coefficients. That's 4 and that's 5. We're going to multiply those, so that's 20. Look at the variables. C to the 6th times c to the 3rd. Keep the base, add the exponents, and you get 20c raised to the 9th power. That's the answer. Now you might be thinking, do I really need to write this down where I'm adding the exponents? Do I need to show this? The answer is no, you don't, but it's a good idea to do it so that you don't forget an exponent and you don't make a mistake. Number 11, 8x to the 4th times 3x squared. Now, these have parentheses around them, but that doesn't matter. We can write that without parentheses. So what do? Take the coefficients, multiply. 8 times 3 is 24. X to the 4th times x to the 2nd. We keep the base. When you multiply the variables, you add the exponents. So we get 24x to the 6th. Okay, now I'm going to stop here. That's part 1 of the notes. Now we're going to continue in a moment looking at number 12 and on, and let's do some of these more complicated problems.